Encoders. Introduction. Encoders are used to translate rotary or linear motion into a digital signal. Usually, this is for the purpose of monitoring or controlling motion parameters such as speed, direction, distance, or position. The encoder is an electromechanical device that can measure displacement. Encoders are normally digital displacement transducers consisting of mechanical element and a sensing head, typically of optical type. The digital output producing sensors are most important because nowadays the processing devices are digital in nature. If suppose a sensing device produces an analog input output, then we require a microcontroller or microprocessor is processing the signal, means definitely we require a analog to digital converter. Now in this case encoders are producing direct digital signals, so there is no need of using analog to digital converter. The mechanical element can be a disc or a ruler with deposited or carved patterns T. The sensing head includes the light source and light sensor photodetector to read the generated code, means the encoded output. This is the diagrammatical representation of optical encoder. It contains coded disk, light sensor assembly, it means phototransistor, an opaque area, transparent segment, LED light source assembly, and sensing shaft. The optical encoders typically consist of rotating and a stationary electric circuit. The rotor is usually a metal, glass, or plastic disc mounted on the encoder shaft. The disc has some kind of optical pattern which is electronically decoded to generate position information. The rotor disc in absolute optical encoder uses opaque and transparent segment arranged in a gray code pattern. Gray code in the sense only one bit change occurs for the next number. The stator has corresponding pairs of LED and phototransistors arranged so that the LED light shines through the transparent sections of the rotor disc and received by phototransistor on the another side. After the electronic signals are amplified and converted, they are then available for evaluation of the position. Working of an encoder. With this encoder, the displacement is obtained by counting the number of times that transitions occur between the logical values zeros and ones. It means the either side of the disk contains LED light source as well as photodetector. When the open area comes, the light is passed through the transparent area and reaches the photodetector. Then that time it gives 1. Otherwise, the output is 0. So either the output will be two voltage levels, either high or low. This allows the transformation of physical quantities by converting the angular displacement variations into electrical type signal output that is translated into logic values by suitable electronics. The counting of the number of transitions that occur in the disk sectors is related to the concept of resolution. The resolution may be defined as the smallest change in the quantity under measurement that causes a noticeable change in the corresponding outcome. In this case, the resolution of the disk corresponds to its minimum angular variation that causes a transition at the logical output level. As there are 9 0 to 1 transitions in the complete rotation of the disk. Types. The most widely used classification refers to the type of movement, linear or rotary. In both cases, they can be incremental, semi-absolute or absolute. These are all the types of optical encoders. Next one is magnetic encoder. Magnetic encoder detects rotational position information as change of magnetic field, converts them into electrical signal and outputs them. The simple magnetic encoder consists of permanent magnet and a magnetic sector. The permanent magnet is attached to the tip of a rotating body such as a motor shaft, and the magnetic sensor is fixed in the state where it is mounted on a PCB board at a position where it receives the magnetic field generated by the permanent magnet. When the permanent magnet attached to the motor shaft rotates, the direction of the magnetic field detected by the magnetic sensor changes. As the result, encoder detects the rotational position and speed of the motor shaft. The diagram gives the magnetic encoder setup. The rotor contains a magnet, and for sensing part it is a Hall sensor. When the motor shaft rotates, the magnetic field created by the permanent magnet attached to the tip of the shaft also rotates. At this time, the magnetic field rotates with constant strength in the area near the center of the rotation axis. The Hall element detects the change of magnetic field distribution and converts into electrical signal. The Hall element is a magnetic sensor that can only detect the strength of the magnetic field in the single direction. In this case, the resolution of the disk corresponds to its minimum angular variation that causes a transition at the logical output level. As there are 9 0 to 1 transitions in the complete rotation of the disk. Capacitive encoder. A capacitive encoder works by measuring the change in capacitance from the change in dimension of the capacitor. A capacitive encoder uses the change in capacitance value of a capacitor as a means to measure displacement. Typically, the capacitive sensor's principal elements are arranged so that the capacitance changes as a moving elements displace relative to the stationary plates of the capacitor. This is the diagrammatical representation of a capacitor. A capacitance is equal to epsilon A by D. Epsilon is permeability of dielectric. A is overlapping area of the plates. D distance between the plates. If the area of the plate increases, the capacitance also increases because they are in directly proportional relationship. And the distance between the plate increases, the capacitance decreases because that is inversely proportional relationship. Typically comprises of three main elements: a transmitter, conductive plates separated by a non-conductive material, and a receiver board. Capacitance varies in proportion to distance of the plates as well as their overlap. Displacement can be measured axially or in the planar direction of a plate overlap. Working. An inductive encoder detects a linear displacement or rotation relative to a target. This type of sensor reacts to the presence of ferromagnetic or electrically conducting metal in a target. The rotary or linear encoder contains a transmitting coil which contains four receiver coils. The transmitting coil generates an electromagnetic field. This field is manipulated under the encoder when a copper object enters the electromagnetic field. The receiver coils detect this manipulation and converts the measurement into a movement. In other words, it is a digital output. The encoder is moved over a target with copper markings that are placed in a respective pattern with a ratio as follows. The width of each marking is 2/3 and width of the gap is third. Together, these dimensions make up the period length. The system converts the movement into an analog signal in shape of the sine and cosine. The analog signal is then digitized in the encoder in the shape of square wave. Advantages of inductive encoder: it is compact in design, accurate in measurements, and insensitive to external interference, insensitive to drift dirt. Application: an inductive encoder can measure rotation in an electric motor. It detects the steps of the rotation and feeds this back to the motor controls. The next application is it may be good match for mobile device powered by battery. This is the way this technology is used in applications such as gyroscopes. It consumes low amount of power, that's why it is suitable for mobile applications. An inductive encoder can also be used to automate the zoom feature of a camera. It detects the position of the motorized zoom. Next and final application is the rotation of a gear can be directly measured on the gear without any necessity of a target. In this case, the gear must be made of ferromagnetic steel.